Okay, so we'll look at a few past paper IB questions on sets, focusing more on Venn diagrams this time. Number 1, the sports offered at a retirement village are golf, tennis and swimming. The Venn diagram shows the numbers of people involved in each activity, and so we can see we've got our universal set. We now denote this with a U, but back in the days of about a dozen years ago, they used a different notation which looks like a really curly E. Don't worry about it, we'll just use U. It's worth noting, this is something that students often forget, is that there is a number outside our three circles, so don't forget to look for one, because that could comprise the part of the total number of people. So part A says, how many people only play golf? Well, here's our golf circle, and we can see that this one person, although they are in the golf circle, they're also in the swimming circle, so they must play golf and go swimming. And you can make similar arguments about this 2 for the golf and the tennis, or this 3 who obviously participates in all 3 sports because they belong to all 3 circles. In fact, the only number in the golf circle, which is in the golf circle alone, is 11. How many people play both tennis and golf? Alright, well, we just had to look at that, right? There's the tennis circle and the golf circle, and the overlapping region in between them, there's this 2 and this 3 in it. Now, the question doesn't say play both tennis and golf but not swimming. We're just looking for people who are involved in both tennis and golf. As it turns out, 3 of them also happen to swim. But we do have a total of 2 plus 3, or 5 people who play both tennis and golf. And how many people do not play golf? That must mean that they are not inside the golf circle. And so outside the golf circle we have these 8, and these 4, and these 6, and don't forget these 4 as well. And so that's 8 plus 4 plus 6 plus 4 is a total of 22. And part B, shade the part of the Venn diagram that represents the set G0 intersection S. So we need to have things that are not in circle G, or set G, but are, or and are, in circle S, or set S. So where are my places outside circle G, but inside circle S? We're going to have this region here. Number 2. A group of 30 children are surveyed to find out which of the 3 sports, cricket, basketball or volleyball, they play. The results are as follows. Part A, we need to draw a Venn diagram to illustrate the relationship between the 3 sports played. Now, I know I said that you should start with a rectangle, but when you're dealing with 3 circles, I would probably actually draw the 3 circles first, for the very easy reason that if you draw the rectangle first, you might find that you don't have enough room to draw your circles comfortably. I find it actually a lot easier to draw my circles first and then draw my rectangle for my U, my universal set around the outside. And I've got these 3 circles representing cricket, a C, basketball, B, and volleyball, a V. Now let's fill in the information. 3 children do not play any of these sports, meaning that they are not inside any of these circles. Well, they must go out here. 2 children play all 3 sports, meaning that they must be inside all 3 of the sets. There we go. 6 play volleyball and basketball. Now this is where we have to be careful. It doesn't say 6 play volleyball and basketball but not cricket. It simply says 6 play volleyball and basketball. Some of these 6 might also happen to play cricket. So there's going to be a total of 6 in the overlapping region between basketball and volleyball. 2 of them we've already used in the cricket playing group. That must leave another 4 outside in order to make a total of 6. 3 play cricket and basketball, so the same line of reasoning. The cricket and basketball overlapping region, the people who belong to both sets, has got a 2 in it already who happen to also play volleyball. That must leave only one of the 3 who does not play volleyball. 6 play cricket and volleyball. Again, we've already used the 2 of them here, and this region must be 4 to make that total of 6 who are in the overlapping region between the cricket and volleyball sets. 16 play basketball. Alright, so there's a total of 16 in the basketball circle. It doesn't say basketball only. That would mean we'd put the 16 here. It says basketball. And they could play other sports as well. 4 plus 2 plus 1 is 7. That must leave, in order to get a total of 16, that must mean that there's 9 remaining. And 12 play volleyball. In the volleyball circle, we've already used 4 plus 2 plus 4. That's 8. That's 10 so far. In order to get up to 12, there must be another 2 here. So, there's really only one region left that we haven't filled in, and that's the people who play cricket and no other sport. How are we going to get that? Remember at the very beginning of the question, they told us the total number of children who have been surveyed. Let's find out how many of those children have been represented so far. So we've got 9 plus 1, that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, plus 2 is 22, plus 3 is 25. That's a total of 25 students. How many children play only cricket? Well, we need to have a total of 30 in the diagram. That must mean that there's 5 remaining here. I'm just going to call it x, and we'll say that this x value must be the total minus the sum of all of the others. So 1 plus 9 plus 2 plus 4 plus 4 plus 2. And the 3 on the outside too, right? Okay, and that equals 30 minus 25. And so we have 5 students who play only cricket. Number 3. In a club with 60 members, everyone attends either on Tuesday for drama or on Thursday for sports, or on both of these days for both drama and sports. On one particular week, it is found that 48 members attend for drama and 44 members attend for sports, and X members attend for both drama and sports. Draw and label fully a Venn diagram to illustrate this information. Alright, here we go. I know I said a moment ago I should draw my circles first. I probably should have, but I know that this one's only 2. I'm capable of drawing my 2 circles fairly well inside a rectangle. 3, I find it a bit challenging. Okay, so here's our drama circle, and here's our sports circle. I'm not going to worry about these days, Tuesday and Thursday, because those are directly linked to these drama and sport activities. So we've done, we haven't finished part A, because we still have to fill in this information about the 48 members attend for drama. That means that the drama circle is got 48 members in it, some of whom are in here, and some of whom are in here. We've got 44 members in the complete sports circle, some of whom are in here, and some of whom are in here. A common mistake for students here would be to write the 48 immediately, to write the 44 immediately. Well, don't forget that there's some of those 48 and some of those 44 could be in this region between. And that is what we would label as X. X members attend for both drama and sports, so let's fill in the X here. Now we want a total of 48 in the drama circle. X of them have already been used in this circle. How many must be left in here in order to get a total of 48? One way you can do a problem like this is just to substitute an imaginary number for X. Let's pretend X is 10. How would you calculate the remaining number of people in this area knowing that there's 48 in all? Well, if 10 of the 48 have been used here, how would you get this? We'd have to take the difference, 48 minus 10, in order to give us 38. So now then, let's just do the exact same reasoning, except instead of a 10, we have an X. So instead of 48 minus 10 in this region, we'll have 48 minus X in that region. And if if we added these two parts together, 48 minus x in the region on the left, plus x, which is the other people who went to drama, who did also go to sports, as it turns out, this would give us the total of the 48 people in the drama circle, the sum of the two regions. Now we can use the same reasoning with sports having a total of 44. If x of them are here, that must leave the remaining amount, the difference, 44 minus x, in that part of the sports. And we have a club with a total of 60 members. And so the sum of these three regions, plus this region, let's see, hang on. Oh, it says everybody attends either on Tuesday or... That must mean that there's 0 people who attended on neither of the days. It says everybody in the 60-member club attends on one or the other or both. So 0 on the outside. The sum of these 4 regions should equal 60. So let's see what we can do about that. 48 minus x is the first region, plus x, the middle region, plus 44 minus x, the region on the right, plus 0, of course, equals 60. And now we should be able to solve for x. In fact, we're going to be a little bit lucky. This minus x cancels with this plus x right beside it. And so let's bring this negative x over to the right-hand side. And I'll just write it down here below. It now becomes a positive x with my 60. So I just brought this remaining negative x to the right-hand side. It becomes a positive x. One way of saying this is that we added x to both sides of the equation. If we add x to this side, they cancel. If we add x to this side in order to keep the equation balanced, there it is. Here's our addition of x. You might have written 60 plus x. That would also be correct. And we still also have this 48 plus 44 plus 0 to deal with, and those sum to give you 92. In order to get the x alone, we now need to subtract 60 from both sides. Another way you can think about that is that we're moving the plus 60 to the left, and it takes on the inverse operation, minus 60. And we'll find out then that x is equal to 32. And so that's the answer to part B. And part C, describe in words the set represented by D and S, in parentheses, so that's a grouping, D and S, not, with that complement on the outside. So I guess the complement on the outside means that the statement in the parentheses is not true. So we could say then, it is not true so let's see, we've got the statement D, are all the people who are in the drama. And yeah, I've changed my mind about how I want to say this. Sorry to be wishy-washy here, but I'm thinking again. Let me just sort of work out the wording for the grouping on the inside. It says D and S. So that's somebody who does attend drama on Tuesday, and they do attend sports on Thursday. So D and S represents the set of people who attend both Tuesday drama and Thursday sports. So the not on the outside, we must be referring to everybody else. So we're dealing then with the set of club members, should we call them, who do not, because of the complement, who do not attend both drama on Tuesday and sports on Thursday.